So we're going to look at how to prove triangles are similar, or how to use similar triangles when you are doing a proof. We are going to be using a few new reasons that we have learned just recently. I'm going to write them down real quick so you can kind of just see what our new reasons are that we'll need to know. There are three ways to prove that triangles are similar. They are angle-angle similarity, side-angle-side similarity, and side-side-side similarity. Hopefully you watched the video where I talked about each of these and how you can identify which one you might want to use and how they work. Once you have your triangles similar, there are ways that you're able to use those similar figures. One thing that's true about similar figures is that their corresponding angles are congruent. Another thing that's true for similar figures is that their corresponding sides are proportional. So once we've done in the proof, gotten to the point where we prove the triangles similar, our next step is one of two options. We can either say if triangles similar, then corresponding angles congruent, or we can say if triangles similar, then corresponding sides are proportional. Because when your figures are similar, the sides are not congruent, but you can write a proportion with them. Now, sometimes once we have the sides in proportion, we like to cross multiply on that proportion. And if you are doing that in a proof, then your reason would be called the cross product property. So we're going to be practicing using these new rules in our proofs. Now, all of our old rules still apply, such as if you have parallel lines, then alternate interior angles are congruent, or if you have parallel lines, then corresponding angles are congruent, vertical angles are congruent. All of those things are still going to be used in the proofs. These are just our new reasons that we're going to be using. So let's look at our first proof. We have three proofs that we want to do here. We are given a pair of congruent angles in the given. Our goal is to get a pair of sides proportional. So we're going to be proving the triangles similar, and then we're going to use that statement that says if triangle similar, then corresponding sides proportional. In the given, I have angles 1 congruent to angle 2. I'm going to go ahead and mark that in my picture. And we should also notice that in this image, the triangles that we have in this image are overlapping. We have a small triangle, which I'm highlighting in green, and we have a larger triangle that green one is overlapping with. When you have this happening in your image, they're often having a shared angle, and you can use reflexive property to show that that angle is congruent to itself because it exists both in the green triangle as well as the pink triangle. So it's kind of like it exists for two purposes. Now that we've noticed that we have 1 and 2, which was given, and that the triangles share angle V, that's two angle pairs from each triangle. That means that I'm able to prove the triangles are similar by angle-angle similarity. So I'm going to start the proof now. I have my given, and we have our shared angle, reflexive property of congruence. Once you have your two angles, you're able to say the triangles are similar using angle-angle similarity. When you name these triangles, remember that the order you name them matters. You name the first one however you want. I'm going to say VWZ. And then remember that this is similarity, not congruent. Similar sign is just a little squiggle. And then you want to match up your corresponding angles. So since V is the same angle in both triangles, we will start with V. W was where angle 1 was at. We know that 1 and 2 match, so we're going to go to X because X corresponds with W. And then the one that is left that will correspond with angle Z is angle Y. So this allows us to arrange our statement so that all of the corresponding pieces are aligned. Once your triangles are similar, again, from these reasons back here, we're going to go to one of two things. We're either going to talk about how the corresponding angles are congruent, or we're going to talk about how the corresponding sides are proportional. Which one we choose depends on our goal for the proof. In this particular proof, we are trying to prove that a set of corresponding sides is proportional. That's what this is. It's a proportion. So we can easily tell that is the goal. So we're going to go right there. This is just setting up some corresponding sides into a proportion. And we can say if triangles similar, then corresponding sides are proportional. I know that's a long reason to have to write out, but there's really no short way to say that. Thankfully, the other reasons were short. So it's a pretty basic one. We're going to look at a little bit harder one. What makes this next one more challenging is the fact that parallel lines are involved. So we're going to need to think about when we had proofs involving parallel lines. Remember, if you're given parallel lines, you would be using the theorems, the original order, like if lines parallel, then alternate interior angles congruent. But when you're proving that lines are parallel, what you're going to be doing is you're going to use one of those converses at the end, such as if alternate interior angles are congruent, then lines parallel, which is the one that we're going to use on this proof. So keep in mind that parallel lines and angles are related. For this proof, we're going to be trying to use similar triangles to allow us to have an angle pair that will allow me to say that the lines are parallel. So just always looking for angles to get to your parallel lines. In the given, we have two sets of sides in proportion. This leads me to thinking that we're probably going to be using side angle side, because I only have two sides in this proportion. So I'm going to try to label these on the picture. There's no real set way for labeling similar corresponding sides which are proportional. So I'm going to be using the similarity squiggle to kind of mark the matching ones. So BM is the top piece. I'm going to just mark BM with one squiggle. Its corresponding side should be the side that's below it, MC. So if I find MC, make a squiggle. So those are corresponding sides. They're not congruent to each other, but I have marked them in a way where I can tell those are the matching ones for these similar triangles. On the top right, I have NM. So I'm going to give it a double squiggle because it's not the same as BM. And ML is corresponding to it. So give it a double squiggle so you can see your matching pieces. This allows me, when I'm going to go write my triangle similarity statement, to know which pieces are corresponding with what so that I'm able to write that statement correctly. In this image, we also have, I call it the bow tie shape, where you have vertical angles going on. They have these vertical angles in the middle. And so we're able to know that angle 1 is congruent to angle 2. This will get me side angle side. So I have everything I need to get to the similar triangles. So let's do that part of the proof, and then we'll talk about how to complete it. So we got BM and MC equals NM and ML. So that was given. And then we were able to determine that 1 and 2 were congruent because vertical angles are congruent. This is all the information I need in order to use side angle side similarity to state that the triangles are similar. And so I'm going to write my similarity statement. And the first triangle you can name in any order. I'm going to say BMN. And this triangle is similar. And angle B, how we were going to find like some corresponding angles, is to look at where B is in relation to the markings on the picture. It's at the end of the side that has one squiggle on it, and the side next to it has no markings. So we're going to be looking in between the side with one squiggle and the side with no markings, and that would be angle C. These are corresponding for the triangles. So if I start with B in the first triangle, I will need to start with C in the second triangle. Angle M is where the vertical angles are, and those are matching. So I will have to have them in a corresponding spot. And then angle L is at the end of the double mark side, so I need N to match, or L to match with N. So L is going to go last because N was last. So now I have the similarity statement. Again, make sure to put similar, not congruence. Like last unit, we were putting congruence, so sometimes we mess that up. Now, remember that our goal is parallel lines. And in order to get parallel lines, you need to know an angle pair that can help you to prove that. We're trying to prove BN and LC are parallel to each other. Well, I had highlighted angle B and C as a corresponding pair in the triangles, so I think I'm going to use those angles. Notice that if I connect the parallel lines with a transversal, such as line BC, I can see like a Z shape. This shape outlines alternate interior angles. So if these angles are congruent, and we can tell they are because in similar triangles the corresponding angles are congruent, then we can use those angles to get the lines parallel. So my next statement in the proof is going to be to talk about the angle pair I would like to use, and to say if triangles similar, then corresponding angles are congruent. And now we're going to use that congruent pair of angles to prove that the lines are parallel. Line BN parallel to LC if alternate interior angles congruent, then lines parallel. This is also known as the alternate interior angles converse. One thing that confuses people about this proof is that the second to last line referred to them as corresponding angles, and the last line referred to them as alternate interior. The name in these moments depends on what you're relating it to. Angles B and C are corresponding in the image based off of the triangles. So right here where B and C are corresponding, that is because they are corresponding parts of similar triangles. Now, when we go to have them be alternate interior, that is how they are in relation to the parallel lines. So as far as alternate interior goes, that's related to how they are relative to the lines. So you want to kind of realize that, why they're using the different words here. All right, last one. On this one, our goal is to end with a product of side pieces, or corresponding sides, sorry. We have a cross product is what this is. Our last reason is going to be the cross product property, because I can tell that they're multiplying sides, and the only way to have that happen is after you have a proportion when you cross multiply. So we're going to start by trying to get the triangles parallel first, and then since our goal is a cross product which comes from a proportion, we will write a proportion for corresponding sides, and then we will get to our cross product property. In the given was two sets of parallel lines. So we're going to be using parallel lines again. So we have AB parallel to RS, and we have BC parallel to AR. And this was given. And let's look at AB and RS and just see if we can find an angle pair. Here's AB and RS. And notice that they have a pretty good transversal right here that is making a Z shape that involves both triangles. And we can see that this angle and this angle would be alternate interior angles. So the goal of parallel lines is always to get you a pair of angles. So we're going to be able to use alternate interior angles theorem to get that angle and that angle to match. I have another pair of parallel lines, BC and AR. BC and AR, they have this transversal that connects them. And it makes a ziggy-zaggy shape as well, like a Z shape, which is alternate interior angles. Now, you don't want to mark this angle pair the same as the other angle pair, so you want to give it 2 little arcs. It's very important that you realize this angle pair is not the same as the first angle pair. And once we've used both pairs of parallel lines, we have 2 pairs of angles that are matching. And that is enough to say that the triangles are similar by angle, angle. What's important in this problem is to realize that as we're going to be naming these angles in the proof, you either have to name them with 3 letters or you need to number them if there's more than one at any spot. So like at point A, the vertex A has a lot of angles going on there. It has this angle, and then it has those angles together. So we are not able to say angle A. So we might number this 1 and 2, or you might use 3 letters. Like to name angle 1, you might have to say angle BAC. To name angle 2, you might say angle RAS. At point S, there's also multiple angles, so we might call that number 3. Or we could call it RAS, angle RAS. At C, there is only one angle there. So you are able to call it angle C. You could number it as a number 4 and call it number 4 if you want to. But I'm going to call it angle C. Since both of the pairs of angles were alternate interior angles, and we're going to be using the same reason, I'm going to put them on the same line of the proof. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle C. This was using those parallel lines, and when you start with parallel lines and you get angles from it, that is the normal order. That's the theorem, alternate interior angles theorem. You could write that down, or you could say if lines parallel, then alternate interior angles congruent. Sorry for my neighbor's dog in the background. Now that I have 2 pairs of angles congruent, I can use angle-angle similarity in order to prove the triangles are similar. If I say ABC, then I would say similar to, remember that A is where the angle 1 is, and angle 1 is supposed to match with angle 3. Angle 3 is where the letter S is. So in my statement here, A and S are corresponding angles. So S will go in the place that A was first. Angle B has no marking. It's corresponding with angle R. And angle C in the top triangle has a double marking, so it in the bottom triangle has a double marking at A. So we're going to be matching our corresponding angles that way. Now, once you have your similar triangles, you're either using them to get an angle pair or you're using them to talk about proportional sides. We already talked about a bunch of angles here, so we're not going to be needing to go to angles. We're going to be going to sides being proportional. This step in the proof is always the one that I have to be very careful about. And how I do this is I'm kind of backwards deciding if my goal is to have this cross product, which I'm just copying out of the proof statement. If I need this product, then I need a proportion that will get me there. So like if BC is here, I could choose to put it on top. And if it has to have a cross product with RS, then maybe RS needs to go on the diagonal so that those would multiply together when you are cross multiplying your proportion. So you're going to start by choosing one side of this and placing the pieces on the diagonal so that they would give you the cross product. Next, look at the picture and look at where BC is located. BC is over here. And think about which side would correspond to BC in the other triangle. That would be the one that goes from the angle with no marking to the angle with 2 marks. So that would be RA or AR. Then look at how they wrote that in the right side of the equation here. So those are corresponding sides. So those pieces need to go, lining up in a ratio. You put your corresponding sides in a ratio. Then on the right side, thinking of the side that corresponds to RS. Here's RS. It's between the angle that has no marking and the angle that has 1 marking. So then that would be AB or BA. Of course, that's the other one there. And then you're able to put that on the top. So the proportion is just listing 2 corresponding pairs of sides, and you want it to be listed in a way where you're able to get this cross product when you cross multiply. So my reason for the second to last statement is going to be if triangles similar, then corresponding sides proportional. And my last reason, cross product property, because they're cross multiplying. Several of the homework questions have like a prove A and then a B, and they kind of give you steps along the way. Like they might write the proportion for you, and that's like prove part A, and then part B would be the cross product. They're just trying to kind of help you get to the cross product step, but you are likely to need to write that proportion yourself, and I think that is practiced at the end of the homework, so make sure you're practicing all of those proofs on the proof homework. All right. I hope that helped.